All right, let's get right into it. Welcome, future dynamic positioning operators. Today, we're diving into what is arguably the most critical briefing of your entire maritime career. We are breaking down Ivan Martinenko's 2025 deep dive into optimizing operator training. Look, you're here because you're going to be trusted with vessels worth hundreds of millions of dollars, operating in some of the most brutal conditions on the planet. As your instructor, I don't just want you to pass a test. I want you to survive, and I want you to save the rig when everything goes completely wrong. So you might be wondering, why do these flawless DP computers even fail in the first place? I mean, modern systems have millimeter precision, triple redundancy, and incredibly advanced algorithms. The tech keeps getting better. But here is the wild paradox. According to the latest data from the International Marine Contractors Association, IMCA, catastrophic position loss incidents are actually going up. How is that even possible? Well, the machines aren't perfect, but they aren't the main problem either. Look at this number, 76%. This isn't just a fluke, it is hard IMCAD data. The vast majority of these catastrophic failures aren't because the hardware broke down. They are a direct result of our own decision and action errors. A sensor might fail, sure, but it is the human on the bridge who turns a manageable problem into a full-blown disaster. So where exactly does our mental breakdown happen when the bridge alarms start blaring? Let's break down this IMCI data. 38% of it comes from action errors, literally pushing the wrong button in a panic. Another 38% are decision errors. This is huge. It highlights a massive lack of decision-making skills in critical situations. You just freeze up. Sensory and memory errors make up the rest. Basically, over 3/4 of all incidents happen because your decision-making completely collapses under real crisis pressure. But today, we are going to change that. Here is our masterclass curriculum. We're going to cover the anatomy of human error, the psychology behind cognitive load, team leadership, beating automation bias, our simulation action plan, and finally, your readiness checklist. Let's dive right in. Starting off with Section 1, the anatomy of human error, or as I like to call it, the ticking clock. Let me walk you through the terrifying reality of an emergency like a drive-off or drift-off. Time is literally your worst enemy here. Those first 10 seconds, that's just you processing the initial alert and confusion. You have a window of about 40 seconds to assess the situation and smash that red alert button. If you don't, by the 70-second mark in a full drive-off, your vessel has shifted 70 meters. 70 meters! If you've got divers down or you're connected to a well, that means broken pipes, destroyed equipment, and potentially lost lives. You do not have time to form a committee to discuss it. Which brings us to Section 2, Psychology and Cognitive Load. Let's look at what happens to your mind under extreme stress. To survive, you have to understand the psychological battlefield inside your own head when a sudden blackout hits. Normally, your cognitive load is fine. You see the big picture, you make logical choices. But under severe stress, your brain actually betrays you. You get cognitive overload. You develop tunnel vision, staring at one single blinking alarm. You jump to premature conclusions, and your memory literally impairs itself. You forget basic protocols because you just can't process all those complex variables at once. Moving to Section 3, Team Leadership. Remember this, you are absolutely not alone up there. Surviving a cascading equipment failure is not a job for a lone wolf. Trying to handle it all yourself leads directly to disaster. I love this quote based on Herdzik's research. Communication and teamwork at the organizational level are your lifelines. If you aren't flawlessly coordinating with the master and the engine room, you are doomed. The psychological aspect of shared responsibility is absolutely critical here. Let's map out exactly what that leadership dynamic looks like. The DP operator focuses entirely on system status and the manual override. The master steps back and handles overall vessel safety and command decisions. Meanwhile, the engine room is laser-focused on restoring power and blackout recovery. This exact role clarity prevents organizational chaos when the load gets high. Do your job and only your job, because remember, we only have those 40 seconds. Section 4, Beating Automation Bias. This is, without a doubt, the enemy of vigilance. We are now looking at the most insidious threat to modern operators, automation bias. Essentially, the autopilot is so good for so long, you start using it as a crutch. You trust the automated cues so much that your manual skills erode and you stop actually looking out the window. This unwarranted trust makes you incredibly vulnerable when the computer inevitably starts lying to you. You absolutely must watch out for these key risk indicators in yourself. Are you waiting for an alarm before you act? That's an omission error. Are you following a screen that says everything is fine while the ship is clearly drifting? That's a commission error. Are you skipping your verification checklists? If you do these things, you have lost your situational awareness, and you are trusting the machine way too much. So here is your step-by-step tactical protocol for transitioning to manual control without making things worse. Step 1. Filter your alarms. Don't read everything. Find the core issue to reduce your cognitive load. Step 2. Independently cross-verify the system status. Look at other sensors. Step 3. Assess the environmental forces around you, wind, currents. And Step 4. Execute the manual override with precise, deliberate thruster allocation. Take the wheel back smoothly. Section 5. Our simulation action plan. This is how we are preparing for the absolute worst. To get you ready to override in seconds, our whole training paradigm has to radically shift. The old standard training was easy, less than 20% emergencies. It just gave you a false sense of security. But our optimized framework, we are throwing emergencies at you at least 40% of the time. We are building real stress inoculation. You need to expect the machinery to fail. Here is the rigorous simulation exercise plan we're going to use. Step 1. We induce negative first impressions. We will expose you to system failures early on so you learn not to trust the computer blindly. Step 2. Dynamic scenario evolution. We are going to crank up the time pressure and make you verify complex data when the sensors contradict each other. Step 3. Multi-personnel blackout recovery. We will drill this until your manual control skills and communication are pure muscle memory. Finally, Section 6, the readiness checklist. This is your ultimate test. I'm going to rapid fire this checklist at you, and I want you to honestly assess yourself right now. Have you truly mastered manual thruster allocation? Have you actually practiced tactics to manage your cognitive load and stress? Are your communication loops clearly established? Do you completely understand your system's limits? And the biggest one, are you ready to assess and execute an override in under 40 seconds? Think deeply about it, because out there on the water, you don't get a pause button. When the alarms sound, the system fails, and the rig is right next to you, will you be a controller or just another casualty in IMCA statistics? The choice and your preparation is entirely up to you. Thanks for joining me for this briefing today, and stay vigilant out there.